image that's here.
Alright.
So that's the same orientation it's going to go. So I'm going to take it from here.
Oh my goodness. You don't have to, like, how does it go there? It's
It's-
just magnetic?
It has these kinematic positioners and then 3 magnets hold it in place. So the magnets are these right here and then these kinematic ones. So it's total system, it's 5 microns of where it was. So it's very, very good.
I'm
Yeah,
just
go
gonna
ahead.
zoom in over here. Okay.
Now let's load a sample.
Sample loading is the same?
So this'll, yeah, it might be good to get a second set of tweezers. We only provide one, but these are, you shouldn't really contaminate with sample stuff. But since these are just these it's fine. So here in the center, there's a place to put the magnetic holder, or you can clamp down glass slides here. And these you can move around to any of these positions. So, okay. Now this has a little symbol, like an arrow here.
Mm-hmm.
On the stage, there's also that same arrow. So that's how it's going to go. It just clamps in.
So if you have a small glass slide, like I sometimes incubate cells or something on the round one, like the microscope slides.
So
Not
what-
microscope, not the slides,
Yeah.
but around.
Yeah, what I would do is actually put a standard glass slide down and then use
On top of
vacuum
it.
grease or something to stick that down to the other slide.
Okay.
Yeah. What you need is just basically that it's well fixed to the
Right.
to the stage.
I just thought there was something there.
Oh, there's a little
Okay.
ca- it's like a wrinkle in this ribbon cable. So for the profusion, things like that, we're interested in doing, you can perfuse through the back here. There's some soft foam, or you
Mhm.
can even remove this, and then you can clamp it down here, make sure it doesn't move around.
Yeah,
You can also remove these on the side and go
Okay.
it through the side if you need to,
I see.
for gas or whatever.
Yeah,
perfusion.
I'm not sure.
Yeah. Okay, so now when I start to close it, there's a tilt sensor and you'll see the laser turn on there. Okay.
So the laser is not on when you're working with
Yeah,
it
for
like
safety,
that?
we
Yeah.
have, make sure it turns off so you don't
Awesome.
stick your eye in there.
Great.
It's a class 2M laser, means that if you directly look at it, the blink reflex is enough to
Just,
keep it safe.
but if you just stare in it.
Yeah, if you like hold your eye open, then yeah.
You never know with our students.
Yeah, I know, right?
Do we need to put a
We probably
sign
should, yeah.
that, yeah.
Laser.
Yeah, class 2M, class 2 laser. Also, if you're looking at it through like a magnifying glass or objective, then
Like it focuses.
then class 2 is not safe,
Right.
because even if you have the blink, there's enough damage that's done. But you don't have a microscope. That's mostly when you put it on an inverted microscope. So let's talk about laser alignment now. So I've loaded the sample, I've loaded the cantilever, all that. Now I have the mode, and I select select the mode, and now I have to select the cantilever for that. And the one here is actually Shocon. It's not the let's see, Shocon. Yeah. And actually, I think
come up with that name?
short contact mode with
Oh.
this G means that there's gold on the backside.
So cold. That's like.
So the ones I provided are these Shocon A's, so
Alright.
it's the same cantilever but it has aluminum backside.
Aluminum, so A is from aluminum. G
Aluminum
from
is
gold.
is not good for liquid imaging.
Right.
It has much better reflectance, so it's better to use in general. But if you're gonna use it in liquid, you have to make sure the pHs are right, or else could get the things that come off.
Yeah.
Yeah. So, if you notice, that isn't on this list, so we can actually add that. And so I'll show you how to do that. We go to Cantilever browser here. Expand this. Add a new one. This one is a show con. Doesn't matter A or G because
It doesn't matter.
yeah. Manufacturer is App Nano. Spring constant, does it say on there? It'll probably give you a range. So 0.01 to 0.6. So just pick a number in the middle.
0.4.
0.4, sure. The length is 225. Width is about 50, I think or 46. This doesn't matter, this half angle. What happens is that when you store an image, take an image, it'll store this in the file too. So if you want to go back and you know what the half angle is, or want to know what the half angle is, it'll store it there. But for imaging purposes, we don't use that. We also don't care what the tip radius is, but 7 nanometers is probably about right. It's less than 10, so. Now the important ones, especially for a tapping mode cantilever, are the next two values: the resonance frequency and the Q factor. This is a contact mode one, so not so important, but it has a range of between 8 and 37. So we want to pick a number in the middle. So 20 should be about right. And then the Q factor here, we don't know it. That's not usually what they put on the box anyway.
Right.
But 50 for something like this is probably about right too. Then then the resonance frequency in air. In air, it's about 3 times less. Or sorry, in liquid. So let's do 5 kilohertz. Q factor is going to go down to 5, etc. Really, the important ones are these two values. Yeah, are these two values. Because when we go to tapping mode and do an automatic tune, it's going to look around this value. And if we have that way off, it's going to start looking somewhere where there is no resonance, and then it won't find it. So
We're not doing vacuum.
yeah,
So.
for contact mode, actually, the more important one is what the spring constant is, because that's what we're going to use to apply the force if we don't calibrate. So actually, I want to do 0.2 because I think these are more closer to 0.2. Okay, so now we can go here and select the cantilever, show con. Now, from this list, there's some cantilevers that you'll never use, you can go ahead and delete them if you don't want them populating the list. If it gets too many, for example. So I'll go to show con, and now I've set it up, and so now what we want to do is do the laser alignment. So click laser, and now we have the dialog here. So that's actually another thing we should check, is to make sure that you could see the cantilever, and for some reason the intensity is always way too high.
So what did you switch? You switched something?
So I switched the camera position.
Top
Yeah.
view.
Yeah, so right now this is the top view, and if I just switch this, it goes to side view.
It recognizes too. It's a side view.
Oh, yeah. Okay.
Can I
On the
just try
back,
switching that one?
So you're doing that by that bar?
it's a manual.
Okay.
It's
No,
not
no, that's fine. I just
automatic.
didn't know what.
Typically you do this once. You use side view for approach,
Yeah.
and then once you approach, or get close enough, you switch to top view, align the sample, and then that's usually it. If you change between air and liquid, you might have to adjust the focus, and that's done by these two bars on the back. So the one here is the side view, and this is top view. So if I just turn this, I would adjust the focus. Is that coming out of focus? I can't really tell from here.
Yeah.
Mm.
Yeah.
If you're staying in air, you don't have to change this focus. It's usually going between air and liquid.
Right, because you're the
refractance.
extra.
Yeah.
the extra refractive.
let's go back to laser alignment. So, before we started, I actually totally,
I'm sorry, where was the laser?
oh, yeah, sorry, this button here, laser alignment.
Alright, I see.
So you'll get this window.
Mm-hmm.
The top here is your sum signal.
I don't see the green dot.
Yeah, because it's totally off. If it's
Oh,
totally
okay.
off the detector,
Okay, then it's
you
not
won't get
gonna
anything at
okay.
all. I don't know if there's a warning or anything, so.
Just says 0%.
Yeah, right here this
Oh,
says
laser
laser off
off.
or not on
Okay.
detector. If we should see a little dot on there. So, for the most part, if you haven't really touched it,
That's good.
it's gonna be okay. But I've purposely messed it up.
Alright.
So what I do is I go and lift it up just a little bit so I can see the laser spot, right? And I'm gonna go and find now the cantilever. So this is the process, and actually let me draw this so it makes more sense. You have the chip and you have the cantilever. And the laser can be anywhere here if it's messed up. So the first thing I want to do is move it in the Y direction and toward the cantilever until it hits the edge.
Yeah.
And then it's going to disappear from view. I
Yeah.
can see it there, it's going to totally disappear.
And then you come back a little
Yeah.
bit.
And then go across this way until I see it, and then it disappears, or it disappears and I see it again,
Yeah.
and then I come back and have it rest here, and then I move it to the end.
Where you see the pattern,
Yeah.
Yeah.
See
So
the pattern? Okay.
the diffraction pattern.
yeah, you might be able to see that. Yeah, it'll start to refract a little bit. So obviously there's a bright laser spot there, so it's the cantilever's not blocking it at all. I want to start on the top
Oh,
here.
I see. So that is, this is the laser.
That's
like
laser.
These two, and this is the detector.
Yeah, and then this is X in the laser and Y. Right?
That's
Can I
pretty
just-
straightforward.
So, sorry.
I should have moved this.
Got it, okay.
Y.
Okay, I see it, so,
It's
okay.
up, and then X is this way. I guess the arrow points in what
Right.
it's gonna do. And then here it's the same. This is Y now and X, so it's X, Y, X, Y. So first I wanna start with the Y, right? I wanna move it. I always forget which direction to go. So I'm turning it counterclockwise and it disappears there.
Alright.
Okay, so we shouldn't see it on that yet, but so now I bring it back out.
Oh, you see it
Yeah,
already.
you
Oh.
can see the red.
Oh, on the camera, yeah. So I'm right at the edge, right? I'm right here
Yeah.
on the edge somewhere. So now I want to go in X. So I take that out, put this in here. Now I go in X. You see that?
Right
How
there.
it disappears?
Yeah. You can see it on the camera.
Yeah, you see it on the camera?
Mm.
But on here, I see it's gotten blocked
Yeah.
a little bit.
You're still gonna see a little bit,
Yeah.
like leaking on the.
So that might be a reason to put the screen closer to here so it's easier to see.
Yeah, that's, yeah.
Okay, so now I'm on it, and now we should actually see it on the sum signal. The
We see
top
it.
bar.
Yeah.
Okay, so
24, it says okay.
now what I wanna do is bring it back out, and now it disappears on the camera, but it's really bright here. That means I'm off the end here, so I wanna just bring it back until it
Right
disappears
on the
here,
end.
and it appears there.
Okay.
Now you can like try to maximize the sum if you want, but right anywhere in the middle of that green bar is fine. You'll find if you use like a gold cantilever, it'll be less, the sum signal will be smaller.
The green dot is way up over
Yep.
here at the
This is
side.
the detector.
So yeah, now we can close this, put this down, so we're on the cantilever. You can see it in the video, so we can.
So you said, if it's
Center a
right
little
in
bit
the
better.
middle of the bar, right, that's okay?
Yeah. I've never really seen it much higher than this, maybe up in here sometimes with some cantilevers that
Oh, is
More
that like the
reflective.
sum signal?
are, it's a sum, yeah.
Okay.
As long as you're not here in the bottom. And I don't know why we have a red bar on the
Do you
top.
have like an idea of, it doesn't give you its percentage. I like some
Oh, the actual
cantilevers, they would-
voltage?
Yeah,
No,
exactly.
we don't have that. It's a percentage of the total power that,
Okay.
I guess, it's a 10 volt signal coming out of there, so that's
5 volts.
5 volts.
If it's 53.
Yeah. Now we wanna center the, spot, so it's in the quad detector, but it's way off. So.
And is this also like, I remember the detector is not as straightforward as the laser. Is it like you're pushing it somehow?
Yeah.
Or it's you
It's
have
a
to
little
go
more,
back and
it's
forth,
a lot,
right?
oh, no, you just do one.
Okay.
They're independent.
They are?
Yep. It's a lot more sensitive.
Okay.
And when I said the alignment grooves, the laser will be on there, this actually was one thing you might have to change. So you don't have to really change the position, it'll be on the cantilever, but you might have to change the detector.
Okay.
So we went between a tapping mode and contact mode and it was way off the scale, but, and that's alignment, so it's centered. Even though it was way at the top, you could still image, because as long as it's green,
Yeah.
it's there. So I'll show you if it's totally off the detector, yeah. So, the sum signal disappears, so we're getting nothing to the signal. Now, this is a low, so I'm right at the edge, so it's a low sum signal, and we get a flashing red. And now it's on the detector, but it's way off to the top.
Should we record the detector signal intensity? That's not a valid.
It'll be recorded in the file.
Okay.
It'll tell you, it'll have a line that says the sum was this. So
Okay.
laser power was this. Okay, so let me.
And at what rate does that decline? Or should it not? It should not decline.
It shouldn't change too much.
Okay.
Unless you're picking up
Stuff on your
stuff.
cantilever
Okay.
and-
If you're imaging in liquid, then yeah,
Yeah.
all
Okay.
bets are off. So now